So on measure Slack, I put a yeah, you can take that out. Right. So anybody who doesn't know, Simo plays a mean. No, not yet, not yet. What was that? Did I do that? Hello, can you hear me? Yes. Hello. Okay. So can you hold the mic for me while I get dressed? So on measure Slack, I actually asked if anybody would like me to choose music. They could send me an email or something. So Simo introduced me to this really cool song. It was by John Cage, and it's called, I Googled it trying to figure it out, it's called 4:33, 4 minutes and 33 seconds. So the seminal work of John Cage for 4:33, and normally I actually don't respect people's requests or wishes, certainly not Tim, but I'd be happy, I decided that we're going to be able to do this together, and I'm going to sing, and Simo will, he plays ukulele, but I think he'll do a fine mandolin for this piece as well. Right, ukulele, that's your instrument of choice?
Are you going to play the full song?
Or selections.
Hold on.
I got the lyrics.
Yeah, I have 60 minutes of slides in 40 minutes of time. So.
Okay, so Simo, if you can come here. Simo, I'd like everyone to welcome Simo and Yehoshua for John Cage's seminal work. Let me see here.
4:33.
4:33.
3, 2, 1, go.
Thank you very much.
No, thank you.
Yes. Thank you all for attending. This talk, the title is kind of catchy, but I was forced to figure out a marketing title. So I'm not going to be talking that much about data quality or breakfast. I will be talking a lot about browsers. Trying to do a kind of information dump right now, because there are some time constraints to what's going on in the browser world that I think if we're not up to speed, if we in this room are not up to speed, then no one has a chance. So a lot of the information here will be about kind of research to what browsers are currently working on with regard to tracking protections, keywords being cross-site tracking, cookies, privacy, and all these different angles having to do this. So we'll just jump right in. It's going to be a pretty heavy talk. I'm sorry about that. We're going to go a bit over time as well, so I'm sorry about that as well. My name is Simo Ahava. I represent a company called AP Cheap, but I would like to think of this more as a hobby of mine. It's not what I do professionally. I don't consult around these things. This is just super interesting, and I'm trying to kind of I sound a bit tired because I just traveled over, but I'm actually really enthusiastic about this stuff. So I'm trying to be a bit contagious here and make you guys light up as well. So we will be talking about tracking prevention mechanisms in the browsers of today. And by tracking prevention mechanisms, I'm talking about features that are deliberately engineered to prevent tracking. And we should actually dissect every one of those words in that sentence to get into a semantic argument about each and every one of them, but we'll leave that for beers and just take my interpretations for now, and then we can argue about them later. But we have 5 browsers in this screenshot. We have Edge in the top left corner. Edge was just released a couple of weeks ago with their own tracking prevention technology. The new Edge is based on Chromium, the Chromium project, the same project that is underlying the Chrome browser. You might have missed Edge's release because at the very same day, Google makes this enigmatic announcement about doing something in 2 years' time or whatever. So you might have missed the talk about Edge, which I think is a huge shame because they actually did something really interesting there. But we'll be talking about Edge today and giving them the kind of spotlight that they deserve. There's also Clix in the top right corner, a more maybe obscure browser to many, but Clix has doing some really pioneering work in algorithmic detection of tracking, for example. And many of the things that they've been doing have influenced Firefox because they are basically a fork of the Firefox browser, and there's some give and take between the two. In the bottom left corner, we have Brave with their shields. Brave, I think, is, you can correct me if I'm wrong, but the only browser who's had tracking prevention and user privacy in the front and center since day one. Safari, obviously, have been pioneering many of the things that today are emerging in other browsers. Safari's first tracking prevention mechanism came in 2003, and that's when they started blocking, that's when they were released, and they were blocking third-party cookies by default. And then we have Firefox with enhanced tracking protection in the lower right corner. So these are the 5 browsers that will be fueling much of the talk of this talk. You might notice that a browser is missing from this list, and we will definitely get back to that. Much of this research is based on cookiestatus.com, which is a website, a community effort. It's an open source project. There's a GitHub repository for it as well, where anybody can contribute and share issues. It aims to be an overview of what browsers are doing. It has a table which kind of aligns all these different tracking protection mechanisms with the intent of giving you an overview, a technical overview of what tracking protection means and how it's implemented across these different browsers. So take a look if you haven't already. Much of this talk is based on this data. We'll start with a quick quiz. I need to do this, I'm sorry. Not only to activate you, but also to get a good idea of what I should be talking about today. So it's going to be kind of a choose your own adventure this time. So let's imagine a scenario where we are on our browsers, we are browsing a site called blog.superweek.hu. These are imaginary URLs, I hope. And that's the page we're on. We're on a page called welcome.html. That's the page in our URL bar of our browser at the moment. Don't worry about what the browser is. Just get into your mind palace, and you are now on Superweek's blog. When you load the page, it has an image in it. And this image is loaded from shop.superweek.hu. So it's an image on another domain, basically. And this image is loaded with an HTTP request. It's a GET request, a very normal way of loading images on a web page. The first question, and don't do anything yet, just listen to the tones of my voice. HTTP request includes cookies. So when you send an HTTP request, it can include cookies in it, in a specific cookie header. But which cookies does it include? So when shop.superweek.hu receives the request, they get the request from blog.superweek.hu. The image is the target of the request, and the blog is the source of the request. So which cookies are included in this request? And now what I want you to do is remember the question. I'll repeat it once more. Now, I want everybody to close your eyes. I want to see you go like this, because I don't want any peer pressure. I don't want anybody to be embarrassed about their answer. So just put your hand in front of your eyes or close your eyelids or whatever you want. Okay, and now, without looking, there's photographs being taken, but don't worry, I'll blur you out. Who thinks that in this request, the cookies from the source domain are included? Raise your hand now. Okay? And then you can lower your hands, and then keeping your eyes closed, who thinks the cookies of the target domain, the domain receiving the request, are included in the request? Okay, you can open your eyes. That was about a 50-50 split, I think, for those who raised their hands. A domain has only access to the cookies written on itself. Right, so when a domain receives a request, that request will only include cookies that are written on the domain of shop.superweek.hu. Like, if the cookies are written on blog.superweek.hu, they would not be included in the request. So only the domain receiving the traffic has those cookies included. This will all open up why I'm asking this precise question. Don't worry about it. I have one other question. The same scenario, blog.superweek.hu sending requests to shop.superweek.hu. Okay, blog.superweek.hu, shop.superweek.hu. Close your eyes again. Now raise your hand if you think this is an example of a third-party request. So the cookies are third-party cookies. Cool? Lower your hands. And then raise your hands if you think this is an example of a first-party request. So they are first-party cookies. Excellent. This went much better. So this is a first-party request. I mean, even though that it's a cross-origin request, it's a cross-domain request, that the domain changes between the source and the target. But what matters in this scenario is this part, the top privately controlled domain name, which is superweek.hu. As long as the requests happen within that environment, that domain environment, they're considered first-party requests. And this is absolutely fundamental for what we're about to talk about, because we're going to be talking about how cookies are treated in third-party context and first-party contexts. And now I'm trying to step out of a mindset where we talk about first-party cookies and third-party cookies, because technically that's a misnomer. Cookies are cookies. They don't have an alignment with any context such as third-party or first-party. The same cookie can be accessed in both first-party context and third-party context. And this might sound like semantic dribble again, but it actually does make a difference when we talk about Safari's default cookie policy, for example, because it has provisions for the same cookie depending on in which context it is being accessed. But I'm jumping ahead of myself. But thank you for participating. I'm very pleased with the results, which also means that I can skip 20 slides of introduction to cookies, and we don't have to spend time with that. So let's talk about cross-site tracking. And what, again, this is a term that's used in many different ways. But in this case, and I'm going to tell you what my interpretation is, I'm going with what, for example, WebKit uses. When WebKit introduces intelligent tracking prevention, they have a very specific description for cross-site requests. And the same thing when Chrome and Chromium talk about the same site cookie, that has a very specific definition here. In this scenario, we have the browser on simoahava.com. So that's the URL in the address bar. Now, any cookies on simoahava.com are same site, so it's a first-party context. Any subdomains of simoahava.com would still be first-party context. So this would be a same site request, a same site cookie. There's no third-party things going on. If your browser is blocking third-party cookies, it would still allow these cookies to come through, because that's the same site, it's the first-party context. But then if we have an image loading from something like image.cdn.com, where the top privately controlled domain is different, so it's cdn.com versus simoahava.com, now we are in a cross-site context. This request for this image is a cross-site request. And a cross-site request in this scenario means that it's a third-party context. If your browser is blocking third-party cookies, this request would not include any cookies in it. So this is the definition we're going by today. Now, the reason cross-site tracking, which I'm sure all of you know, but it's good to repeat this, the reason cross-site tracking with cookies is hazardous is because every single page you visit, regardless of what site you're on, if those pages make the request to this cookie, this cross-site request to this cookie, and the browser does not block the cookie from these requests, then whoever is in control of cdn.com can build a comprehensive graph of all the websites you visited on. That's the easiest thing they can do. They can do much nastier things as well. But that's like the easiest possible thing, lowest bar of entry for them. They can just look at all the servers that have been sending requests for that cookie, look at the referrer headers, look at any parameters added to those requests, and then build a comprehensive graph. And that's what we mean when we talk about cross-site tracking. And now, as I said, no, I didn't maybe say this, but I'll say it now. So I'm trying to avoid leaping into specific scenarios, for example, where cross-site cookie tracking could be allowed or legal, or where it's not allowed or illegal. And I'm just trying to talk about how browsers treat this scenario, because this is the fundamental building block of when we talk about tracking prevention. So when browsers start blocking cookies, like third-party cookies, with the intent of preventing this type of leeching. That's a loaded word. This type of exploitation, that's a loaded word. This type of use. when they try to prevent that, obviously the great minds behind our wonderful ad networks and our cross-site trackers have to figure out other ways to do the same stuff. And it doesn't take too much to find out how they're doing this. And there are some service providers, some social media networks in particular, who are very, very good at this. So a very typical way, when our cookies are taken away, what do? Well, we look at other browser storage. So cookies are not the only way to persist state in the client. We have things like HTML5 storage in the form of persistent local storage. We have session storage, which is basically ephemeral. It's deleted between application launches. We have IndexedDB, which is like a transactional database sitting right there in your browser with persistence. So these platforms who used to be able to just drop cookies and read those requests and populate those requests and decorate those links are now having to look elsewhere, and they're trying to take any piece of the browser that lets them persist the information and persist there until their script fires and they can use cookies again, or they can use that local storage. So these are the kinds of things that many browsers are now looking at blocking. So not just cookies, but other browser storage as well. Then we have outbound link tracking. So if you visit Facebook and click any link, it doesn't have to be an ad, any link on Facebook, that outbound link will include the Facebook click ID. So it's a click tracker. I have no idea what they've hashed into that, but at minimum, I would imagine it's your user identity, possibly also a context of what you clicked. But when you then land on the site with this in the URL, all it takes is for any of Facebook's scripts or any of Facebook's partner scripts to load on that site, for them to take that parameter stored in a cookie and then use it later to send information to Facebook or these partners that, hey, this person with this click ID visited this site. So this is how browsers move from the third-party context to your own familiar first-party context. These are first-party cookies now. The URL is in a first-party context. And this is another thing that browsers are figuring out how to block. Brave, for example, just deletes the FBCLID from the URL. You can try it. You can visit any URL and put FBCLID, and suddenly it's not there anymore. Other browsers like Clicks algorithmically try to detect which URL parameters could be user identifiers. So they have a tokenized approach. They look, does this identifier appear in more than one request from this same device? And then they compare it against the global safe set, which is like a whitelisted set of identifiers that should be okay. And if it's not in the safe set, they basically remove it from the request. So these are also being purged. Safari has a lot of protection mechanisms against link decoration as well. Refer is the same thing. Instead of decorating the outbound link, you decorate the page from where the user leaves from. So now it's visible in the referrer header. Well, the referrer header is on its way out. All browsers are actively working against it. Chrome as well. They are moving towards a strict origin when cross-origin header, which basically means that the referrer will always be stripped at minimum to just the origin. So just this part when it's a cross-site request. When you lose the ability to do stateful tracking, so using persistent client-side storage, for example, what do? You use stateless tracking. So you start looking at different flags in the browser. Anything goes, as long as it's something that the browser can toggle on or off. So things like screen height, screen width, user agent, number of plugins on the thing. Even do not track used to be one of these signals, and still is on browsers that support it. We can combine all of these little flags. Alone, they're not very useful, but when we combine them, we can build a fairly unique fingerprint of you. And use that instead of a client ID. Because now we know that as long as you visit with the same browser, it's most likely you. There are some really nefarious APIs, such as the Canvas API, the Web Audio API, which basically take your hardware configuration and use that as a fingerprint. That's really cool. Well, cool is, it's fascinating. So they can actually take stuff that's in your computer that you might have fine-tuned to a very detailed level, all the way from scaling to how your left and right channel in your stereo speakers function, and use that to fingerprint. Fingerprinting is also on its way out. Every single browser has committed to reducing fingerprinting surfaces. Unfortunately, fingerprinting is fluid. I mean, anything that browsers introduce, even tracking prevention mechanisms themselves can be used as fingerprints, which was ironic when ITP was caught red-handed with this. And then there's I'd say, one of the most difficult ones to work around. So when third parties start colluding with first parties, when everything in the browser prevents you from doing anything cool or tracking cross-site, what happens next? Facebook comes knocking on your door, gives you a printer cartridge and says that, hey, print out all these FBCLIDs and just deliver them to this back door in this alley behind the dumpster. And that's how they'll build their own kind of manual DMP. So third parties are instructing first parties how to build server-side proxies, how to circumvent the client, how to take the client out of the equation, how to keep on harvesting that information. And surprisingly many first parties are playing this game. Maybe some out of ignorance, some out of greed, maybe. But I think anybody working with trackers and advertisers have seen these requests. I think Criteo was caught red-handed with it when they actually instructed how to build your own ad blocker circumventing proxy and server-side. So they are really aggressive in how they approach first parties. So it's no wonder that some people are taken with the sales pitch. But this is collusion, and there are like this example is from Adobe, and there's nothing inherently bad with their CNAME approach, but the problem is that when you delegate one of your own domains, let's say tracker.simoahava.com, when you delegate that to Adobe's endpoint, what are you actually doing? Yeah, you're keeping your data first party, but you're also giving every single first party cookie in your browser to Adobe because they're sent with the request. Now, I'm not saying Adobe is necessarily doing anything evil with them, but the potential is there, and the users implementing these things might not understand this. So when all these exploits are emerging left and right, what can we do? Well, what can browsers do? Because I think browsers have grown tired of waiting for sites to do something. That's why Safari took away the DNT signal. They gave the chance for the websites themselves to implement Do Not Track, for vendors themselves to implement Do Not Track. But surprisingly, there was little incentive to do so for many vendors, and then really nothing changed. So I think, I'm not a browser privacy engineer, and I've never been into one of those meetings, but I think that there's a pressure to start taking the initiative. And the difficult thing about this whole mess is that this is another vector into our understanding of what is privacy, what is private data, what can cookies be used for, what is consent. It's another vector, and the problem is that it might not always be aligned with what the legal frameworks do. Browsers are making changes at lightning speed, not necessarily consulting what the underlying legal framework, or what's in the pipelines for these legal frameworks. So it's another thing for us to understand. And the problem is when it might conflict with these frameworks. So just to take a quick look at the past, we have a timeline here of how browsers have been implementing these changes. And I'm going to just kind of run through because there's a lot of detail here that we can skip, but you'll get the slides later on. But in 2003, Safari comes out with their default cookie policy. So Safari blocks third-party cookies without prior so-called seeding. So if you first visit the website in first-party context, so you type Superweek into the URL bar, and that cookie sets a first-party cookie into superweek.hu. After that, the browser is free to interact with that website in third-party context, and third-party cookies can be shipped to and fro. The reason this is a pretty effective change for much of ad tech is because you don't visit those tracking domains first-party. You're always communicating with them in third-party. You don't visit doubleclick.net. But that's where the request goes to, and that's where your cookie is housed in. So this is a very efficient policy, which also, of course, breaks things. Because that's what happens when browsers start blocking things by default. But this has been active for 15 years now. No, that's even more. What's 20 minus 3? I don't know. Yeah, thanks. I'm a bit nervous here. So, in 2013, obviously, disclaimer, a lot of things happen in many browsers. I'm just cherry picking the most fundamental ones that I figured were the most fundamental ones. In 2013, Safari starts blocking local storage in third-party context as well. So you could load a third-party domain into an iframe and interact with its local storage, but this would be partitioned. And partitioning means that the website that loads the iframe and the domain on the iframe, they share a unique store. But then when you go to another website that loads the same iframe, it loads another unique store, and these stores have nothing to do with each other. So that's what partitioning means. So Safari partitions the third-party local storage, making it very difficult to use third-party local storage for cross-site tracking. It's okay. That was very kind. Sorry. That was Siri, right? No. Okay. Cool. There's a Finnish word, Alexa, which is like, are you? And we have Alexa at home, so every time I say like to my son, like, hey, Alexa, käänny pesulla, have you washed yourself? Alexa goes like, what? So that kind of reminded me of that. Anyway, so June 2017, ITP 1.0 was released. ITP is an algorithmic classification system which on device keeps tabs of which domains have cross-site tracking capabilities. It doesn't keep a tab of which domains are trackers, which domains are ad tech, which domains are social logins. It keeps a tab on which domains have cross-site tracking capabilities. These capabilities, there's an algorithm to it, but suffice to say, it basically requires that a domain is requested by the same browser from multiple different sites. Like one of those cross-site tracking scenarios. That's when ITP flags it as potentially having tracking capabilities. And that's when ITP blocks third-party cookie access to it.
Example?
Well, let's say I am simoahava.com, and I want to show my lovely cookiestatus.com, not mine, the community's lovely cookiestatus.com in an iframe, like a widget from cookiestatus.com. By just loading cookiestatus.com in an iframe on simoahava.com doesn't yet really tickle ITP. It's just one domain requesting that. But then when I tell Joshua to put the widget on his domain as well, and then I tell Krista to put the widget on her domain as well, now there's 3 different domains, each requesting the iframe. And if my browser visits my domain first, then yours, then Krista's, that's 3 different domains on my browser requesting cookiestatus.com. And that's when ITP would flag it as classified domain. By purging browser history is the only way to clean it out. And we'll talk about what this means in a bit. But we have, I'm just going to run because Safari has been doing a lot of stuff. A lot of iterations to ITP, a lot of ways to kind of improve the targeting system of ITP for cross-site tracking specifically, especially in the third-party context. Taking some of it back. They had a partitioned third party in the first place, but they took some of that back, and now they just have a global third party. They gave developers a bone by giving the storage access API. So if you have legitimate use for third-party cookies, Safari actually has a documented developer tool for you to implement. It just basically means that you'll see this little prompt. So now in our scenario, I would load the widget with the storage access API, and the prompt would say, cookiestatus.com wants to track you. I think that's the wording. They're not sparing words. They're not mincing words. But they say cookiestatus.com wants to track you. Are you okay with that? And if you say yes, then the storage access API kind of whitelists that classified domain, so third-party cookie access can continue for some time, 30 days to be more precise. But we'll get to that specific. But just look at this. And things start rolling out after ITP1. These releases some of them come like really fast after each other. 2.1 and 2.2 are basically 1 or 2 months apart. And these are fundamental for most of us working in this room. I think this is for many the first time they actually reacted to ITP, because what happened is that they start restricting first-party context as well. It's not just about ad tech and third-party cookies. It's about, because of players like Facebook who are repurposing the first-party context, our ability to use first-party cookies, especially when set with JavaScript, is limited. And this last one it just deserves to be mentioned because, ironically, Google did the research, but they found that ITP, because it classifies on device, so every single device is unique in how they implement ITP, you can actually use that to fingerprint those devices. And some of those attack vectors were, again, fascinating. How they could basically introduce identifiers into subdomain names and then check if those identifiers are classified, because then they'll know that it was this particular device. Really, really ingenious stuff. But anyway, ITP is then adding some additional blocks just to prevent this fingerprinting mechanism. Then we have Firefox around late 2018 introduces enhanced tracking protection in a blog post. And they basically block third-party cookies if you activate it via flags. And they use the disconnect me block list. So very different from ITP. ITP is on-device and algorithmic. Firefox is block list based, open source block lists, and kind of monolithic. If domain is in the block list, it's blocked. There's no mitigations. There's no way to kind of wiggle your way around that, except of course if you know the people who run disconnect me and then just plead to them, which is an interesting discussion for another time. What happens when these, who gets to decide which domains are whitelisted in a block list? Interesting discussion. ETP introduces different modes. So ITP has two modes, on and off. You can allow all cross-site tracking or you can block all cross-site tracking. ETP has standard, the default mode, which strips cookies but doesn't really block anything apart from some fingerprinting categories. But then it has the strict mode, which blocks a lot more. And then it has the, I'm not even sure what it is. Is it basic or something? Or something. But the mode which lets you do the most stuff. But standard is the default. In June 2019, ETP is officially published into the Firefox release. And this means that for new Firefox installs, ETP is on by default. So new Firefox installs start blocking many of the third-party cookies that are rampant on the web at the time. And a couple of months later, ETP is basically set on for all Firefox users. You can go to Firefox settings right now and toggle it off if you don't want it, but that's the reality. It's on right now. Brave Shields is introduced in late 2018. Brave has also a very kind of block listy approach, but instead of using just one list, they use multiple lists, and they use a list that they populate themselves algorithmically. So it's not stored on device. It is a heuristic model. You're still comparing requests against the block list. But Brave also just blocks the entire third-party context from storage. It strips refers. There's no more refers in Brave. These are a lot of very aggressive moves to just cut down these cross-site tracking capabilities. Chrome adds some restrictions to fingerprinting along the way. They optimize their ad blocker algorithm. And then this is the latest. I was a bit underwhelmed by this release actually, because they just have 4 parameters that they're stripping from the URL. FBCL ID, the Google Click ID, the Microsoft Click ID, and the MCE ID, which I think is the MailChimp ID, yeah. So, and these 4 are listed in their GitHub repo because it's open source. So it's not a very powerful measure because you just have to change the parameter name if you want to circumvent it, but it's an idea of things to come. Edge. The tracking prevention in Edge beta is announced in June 2019. So they block cookies from known trackers. They use the disconnect me list, same as Firefox, but they have some of their own modifications to it. They call them trust protection lists. These lists are not available for viewing, so Edge has taken a more black boxed approach. You don't really precisely know what the list is, except that it's based on, much of it comes from disconnect me. Edge beta adds some additional mitigations. So this is where it gets interesting. Edge has mitigations for third-party cookie blocking. If you're engaged with the site, if you're clicking around, filling form fields, basically you get a site engagement score, which is a part of the Chromium project as well. And if the site engagement score passes a certain threshold, that site has access to third-party cookies. So Edge's mitigation is to look at if you're interacting with a site, that interaction signals trust for that site, which is a very interesting choice. They also have mitigations for organizations. So if Edge recognizes 3 different sites like joshuacorin.com, analyticsninja.com, and crazymc.com, and they're all owned by the same company, Edge can kind of share the mitigations across these sites because they're owned by the same company. So Edge has an organizational mitigation as well. And Edge is released, like I said, in January, in mid-January 2020. So the new version of Edge was released then. And this is the Chromium-based build. And then we have Clicks, who introduces their own ad blocking tech. They've actually written a lot of really interesting white papers around this, and they have the Who Tracks Me service, which is also an interesting service to see the status of their tracking. Clicks also introduces this very interesting way to block user identifiers. It's just an interesting tech to read about. And then we have Chrome. So I just wanted to put this here because this is very topical. In February 4th, which is next week, Chrome 80 will be released with the same-site enforcement. So the same-site cookies don't have really anything to do with tracking protection per se, but they do restrict the use of cookies in third-party contexts. So this is more of like a wake-up call. If you know that your organization is actually making active use of cookies in third-party contexts, like SSOs or federated logins, you'll want to audit them pretty fast. And then in 2 years' time, Chrome will be also having tracking protections, which is cool. So this is the playing field. We can see that there's a lot of heavy stuff happening after 2017 when ITP is released. Just as out of curiosity, I aligned it with some events that have taken. So we have GDPR enforcement mid-2018. We have some huge data breaches over here. I'm not seeing any correlation here, but just was interesting to kind of see if browsers are reacting to the amount of data breaches that we're seeing. It's a good idea to bookmark the haveibeenpawned.com website. It's a very interesting source of information for data breaches especially. And at the same time, we have an increasing amount of supply chain attacks. So MageCart, for example, this notorious hacking syndicate or whatever you want to call them, they're doing a crazy amount of these script injection attacks. So they take well-known JavaScript files and hijack them and inject a little bit of credit card skimming stuff there. And then they're running on some of the biggest e-commerce sites in the world and just harvesting credit card numbers. So we have an increasing amount of these kind of exploitations and these kind of speculative attacks. And browsers are reacting to this. But the problem is the browsers can't do this alone. I mean, they can do a lot of stuff alone, but a lot is still left for the sites to control with content security policies, for example. And then if we look at the impact of this momentous shift in our industry, we can see that there are a lot of different things. I'll just skip this weird animation. So obviously there are these things that we consider having malicious connotations or being somehow evil. So we have things like advertising and cross-site tracking and cookie matching and syncing, building graphs and comprehensive audience profiles. All of those are compromised. When the third-party context is compromised, all of these are compromised as well. When these vendors start profiling in first-party context, then first-party context is compromised as well. And then we have these things that we might consider are somehow benign ways to use persistence. So we have login flows, we have state in embedded services, like the widget example. Cookiestatus.com wouldn't be doing anything nasty, but I would maybe need to persist state on it. We have multi-purpose scripts. If Brave starts blocking a specific JavaScript file just because it has cross-site tracking capabilities, what if that JavaScript file also did a lot of UI work on your site? So multi-purpose scripts are also being you have to think in microservices, maybe a bit more. First-party data collection and so on. But the thing is, these are all applications, right? And who's to decide? Oh, wow. Who's to decide what's evil and what's good, right? So all of these can be used for benign purposes and for malicious purposes. And so the browsers have two options. They try to build heuristic models that try to identify these benign and malicious intent from this mess. Or they start doing stuff, let's just bulldoze everything out of the way and then say sorry after the fact. And then start reinstating things that we might miss. And to do this, we get to this question of what is a known tracker? How do browsers decide what trackers are? Well, luckily we've talked about a lot of these already. So Safari has this ultimately on-device way. There is no global block list for ITP. There's no URL for you to go to. What pages are currently blocked by ITP? What URLs? There is the ITP debug mode that you can actually fire up in your own computer, which will tell you basically which domains have their privileges stripped out. We have clicks, which does use a block list, but it also uses an algorithmic approach. So it also populates new domains into that block list by checking what happens on device. Edge does use a block list, but I'm pushing it a bit towards algorithmic because it has these mitigations. So per device, you might have a different experience just because you engaged with the site more with one device and less with the other. And Brave and Firefox are fairly stuck here in the global block list corner. So these are the ways that we try to classify what these known trackers are. And it's still all of these models are heuristic in a way because we're still just trying to figure out when the user loads a request from a domain, does that domain do cross-site tracking? That's the question. And so let's see what they do in third-party context. And I'm just going to whiz through these and stop at the interesting bits. Brave strips all cookies from third-party requests. It blocks all requests to domains in their filter lists. That's why Google Analytics won't load on Brave, Google Tag Manager won't load on Brave. The JavaScript libraries themselves will not load. Any request sent to those endpoints will not fire. Obviously, this is the most hazardous browser for internet user experience because so many libraries have these multiple purposes. And Brave strips all referrer strings from cross-site requests. So if you leave simoahava.com and visit cookiestatus.com, that would not have a referrer anymore because it's a cross-site request. It spoofs cross-site referrers in other scenarios, so instead of showing the referring page, it actually just shows the domain that the request was sent to, which doesn't really help anybody. And it strips these parameters from the URLs, like I already mentioned a couple of times. So we'll skip Chrome for now. Yes?
Was the Bing ads parameter there, was that a misspelling? The previous one?
Was there a misspelling for a parameter MSCLKID, MSCLKID, MS?
I thought it was just MS.
Okay, well, it could be, but don't, yeah. Be vigilant, that's good. Yeah, could be a typo. Clicks blocks cookies in third-party context if target domain is classified with mitigations such as winter. Again, mitigations. Right? So it's a classified domain, but there are mitigations for widget interactions, some redirections, OAuth flows. So mitigations are like the thing that comes to your teeth before the bacteria really get in? Caries? Yeah. So that's what mitigations are for hackers. They start looking at those and start exploiting them. So mitigations are a very difficult topic to talk about. Should there actually be any mitigations? And that's kind of a hot topic as well. They restrict cookies. They have third-party cookies are restricted to a very low expiration if there's no interaction with it first with the site in the URL bar. So if it's only interactions with like doubleclick.net, but you never actually visit doubleclick.net, then those cookies are very restricted. Potential user identifiers are stripped from request URLs. Your Google Analytics client ID is the first to go because that's in so many different requests. It's obviously a user identifier. So that's stripped from those requests. And referrer is downgraded to origin. So referrer strings are pretty useless on clicks as well. Edge blocks cookies if the target domain is in those lists with mitigations that I already mentioned, so site engagement and organizations. And it also starts blocking requests. So the actual request for the JavaScript file is blocked if the domain is identified as having fingerprinting or cryptomining capabilities. No restrictions so far. So it's just blocking or allowing it to happen. Firefox blocks requests to the cryptomining category and also to fingerprinting category, but it requires that the domain to which the request is sent is both in fingerprinting and one of the tracking categories. So a multi-purpose script that is used for tracking but also has fingerprinting capabilities, that would be blocked on Firefox as well. And then cookies in third-party requests are blocked if target domain is classified in disconnect.me. And some other storages. No restrictions on Firefox either. So the browsers that are blocking cookies are making it very difficult for cross-site tracking to survive if it relies on the third-party context, if it relies on those image requests sending those cookie strings to the target domain. And Safari, obviously, may be the most interesting one. Safari is difficult to explain because it has multiple different policies for third-party cookies. It starts with a default policy, which requires that the domain should already have a cookie for it to be accessed in third-party cookies. So you have to visit the domain first and set a cookie in first-party context. if you want Safari to, allow third-party cookies. But there's another mitigation. This is very recent. Not mitigation, but actually, what's the opposite of mitigation? But making it more strict. If you don't interact with the site in first-party context, so you actually visit the site within 30 days, then third-party cookies are blocked. So you actually have to visit the site in first-party context within the last 30 days for Safari to allow third-party cookies. Another, to make it a bit more difficult to harvest third-party cookies. And then last but not least, if it's classified by ITP, it also has its cookies blocked. And all three of these, they're not mutually exclusive, they're all stacked on top of each other. So in Safari, for a third-party cookie to actually get through is pretty remarkable. And just to foreshadow a little, right now in Technology Preview 99, which is the most recent Technology Preview, which assumes that it will soon be in a stable build, Safari will start blocking all third-party cookies, period. There won't be these two mitigations anymore. So Safari will block third-party cookies. Only then, with the Storage Access API, which is the developer tool that the site can request cookie access from a third party, will Safari allow third-party cookie access. Restrictions in third party have to do mainly with the referrer. So Safari is also constricting the information stored in the referrer header, which basically means that, let's go to this list. Let's just reiterate. All these browsers that blocks cookies in third-party request are making it difficult for cross-site tracking to work because that is fundamentally founded on third-party cookies. All the browsers that do something to the referrer string, well, they mainly cause headaches in our lovely analytics reports because much of that relies on what page did the user come from. But also for things like the AMP cache, which basically introduces the referrer as a way to identify was this from the AMP cache or from the actual AMP version of the page. So the referrer string shouldn't matter that much, but I suppose there are use cases where it does. In first-party context, this is a much shorter list, don't worry. Brave does similar things that Safari does, so it blocks JavaScript cookies from surviving past 7 days of no interaction. So maximum expiration of first-party cookies is 7 days on Brave as well. Brave also just expires cookies in 6 months. That's the maximum lifetime of a cookie on Brave, regardless of how it's set. Clicks expires non-HTTP only cookies in 7 days. So if the cookie is set without the HTTP only flag. The HTTP only flag, if it's set to true, it means that the cookie is only accessible in HTTP headers. It's not accessible through JavaScript. So for example, setting the GA cookie to HTTP only would render it useless for GA running in the browser because the browser would not be able to query what the client ID was. HTTP only cookie, first-party cookies are set to expire in 30 days. So Clicks is pretty aggressive on this front as well. And then Safari, obviously, expires cookies in 7 days if they're set with JavaScript. If there's a certain condition in place, meaning if the user clicked a link from a classified domain, such as google.com or facebook.com, if they're classified on your browser, then the cookie, maximum lifetime of a cookie is 24 hours on the page you landed on. So this is to prevent these link decorations from surviving past the 1 day. I'm not sure what the significance of 24 hours is, but we're probably going to see that being constricted even more in the future. And other browser storage, such as localStorage, is also expired with the same conditions. Right now, there's this if referring domain is classified and URL has link decoration, but again, in the latest technology preview of Safari, all script-writable storage is expired, regardless of if the previous domain was classified. So this is our first-party context. It doesn't look that bad when you look at it like this, right? And we can talk about the impact, the relative impact of all of these, not in this talk because we're running out of time, but if we just take a look into the future. Now we talked about the past, we've talked about the present, and now we're going to look at what's coming up. Well, Chrome 80 on February 4th is coming up with the same site restrictions, or the same site enforcement. So basically, in a nutshell, it makes third-party cookies inefficient unless they have a certain flag set. This is used to battle cross-site request forgeries. So a malicious party taking control of one of your API endpoints and kind of piggybacking the user's cookies on that. So this is designed to prevent that. It's not a tracking protection mechanism. It's a security layer in your browser. But the thing is that when vendors start flagging their cookies as same site equals none, it's a signal for future iterations of tracking prevention to start looking at that signal as well and identifying cookies that have specifically been flagged, use me in third party, which is an interesting thing that might happen at some point. The other browsers that are soon to follow suit are the Chromium-based browsers. Clicks and Firefox have also signaled that they're interested in implementing this. Default refer policy moving to strict origin when cross-origin, which means that whenever there's a cross-site request, so a request sent from one website to another, where the top privately controlled domains changes, so cookiestatus.com to superweek.hu, the refer is only the origin, only the domain, basically, plus the protocol. There's no more path information, no more query parameters, nothing in the refer string. Capping the lifetime of all script-writable storage is coming up in Brave and in Safari. So all local storage, IndexedDB, they're all going to have an expiration now. They didn't have any expiration before, except for Safari. So all of that will expire as well in a given amount of time. All cookies in third-party context will be blocked in Safari in an upcoming build. Brave already does it. That's the little exclamation. I should have maybe explained the notation a bit. Safari is playing around with something called the isLoggedIn API, which is very, very interesting if you look at the initial explainer in a mailing list. Basically, it expires all client-side storage if the user does not signal to the website that he or she is logged in. So logged in means logged into Google, logged into the website, logged into a federated login. If the user is not logged in, Safari's approach is that nothing should persist. Everything should be session-based. We'll talk about this much more in the future, I'm sure. And then one thing that all browsers, and this is actually pretty wonderful, all browsers are coming together in talking about private click measurement or ad click attribution, or the ability to measure attribute advertisement impressions and clicks in a kind of way that's conforms to someone's idea of privacy, by also being able to measure conversions against those. And this is an ongoing talk, and it's very cool to see it in the standards talk and not just a single browser going renegade. So they're actively trying to figure out a way how to do this with respect to things like differential privacy and being able to not identify the individual, but to identify them in larger cohorts where the amount of entropy is low enough to not be able to identify individuals. That's the kind of key question. But it's a heated discussion as well. Chrome basically wants to introduce so much entropy that it's still possible to identify almost every human being on the planet, whereas Safari wants to introduce so little entropy that it's basically almost inefficient to do any advertising after that. So it's an interesting discussion going on. I hate this part because I don't really want to tell you anything what you should do and don't, but I'm going to do it anyway. But these are just some experiences that I maybe try to live by or something. Periodically audit the use of client-side state. So now that all these changes are happening, periodically look at what kind of storage you're using with respect to how browsers work, but with also respect to what is actually necessary for doing what you're doing. I know that there are lots of legal frameworks in place and a lot of initiatives on that front having to do with what are necessary cookies and so on, and this doesn't mean necessarily that alone. It's also about just understanding where do you need state, what your browser's share of your website is, and what you need to do about that. What state is absolutely necessary, and what can be kind of ditched because the cost effectiveness of implementing workarounds is too much. Figure out how to incentivize logging in. So the isLoggedIn API is just a proposal at the moment, but we might be seeing something more to that in the future. So just trying to figure out how to incentivize, if you already have a login, how to make it more appealing for users to log in. And we can see this going way overboard as well, where we'll see these fake logins just to get your data. So obviously there's going to be a lot of misuse here as well, but try to figure out the login. Because if you have an authentication system in place, you practically don't need cookies at all. The user communicates with the server, and the server returns a signal. Obviously, you need something in the client to identify that the user is logged in. Set cookies you need in third-party context to same site equals none, with fallbacks for unsupported browsers. Everything older than iOS 12 is unsupported, unfortunately. That's a huge amount of browsers. Utilize Storage Access API if you need third-party storage. So in addition to same site none, read up about Storage Access API and tell your developers to implement that. If you have things like single sign-ons or embedded videos, your own video services or something like that. Consider the browser as a manifestation of the user's desire and intent. So the browser being the so-called user agent, not the site agent, not the vendor agent, not the tracking agent, but the user agent. So you might be tempted to think that if the user is blocking something, maybe they didn't intend to block analytics, so I'll just circumvent it with this little proxy. Well, my recommendation would be to err on the side that yes, they did intend to block the stuff that they're blocking. So don't kind of read too much intent to how users are using their browsers. Do no evil. Oh, that's cliche. Yeah, that was horrible. And do not. So look at server-side analytics as a silver bullet. I know that it's kind of cool to think about all the ways that you can just shift everything to the server. There are some technological restrictions. The server has no idea of who the user in the browser is unless the browser communicates that to the server. So something in the browser must be an identifier or something, or a token that the server can read and identify that this request came from the same person, unless you're doing fingerprinting, which I don't think has a long lifetime. Don't ignore small market share web browsers. Don't ignore what Brave is doing just because they actually have a crazy amount of monthly active users now. Don't ignore what Clix is doing. Don't ignore what Tor browser is doing. I actually have to add Tor to the service as well. Because there's a lot of innovation sharing going on, and a lot of these initiatives are seeping into what the other browsers are doing as well. And a lot of these initiatives have come from these smaller browsers. And the community around this privacy engineering is pretty tight. So a lot of these things are passing to and fro. Don't expect tracking prevention development to settle or slow down. Don't think that we've kind of crossed the hump now that third-party cookies are blocked. Because the bad actors are always going to be one step ahead. Don't spread fear, uncertainty, and doubt about the impact of these measures without empirical data. But this is my personal request. I know it's scary that third-party cookies are dying in Chrome in 2 years, maybe, perhaps, who knows. But let's look at it empirically, and let's look at it scientifically, and let's measure the impact, and then let's participate in the discussions and figure out alternative ways so that we don't lose our livelihoods. Don't expect that browsers will handle the ethical or legal side of data collection for you. So don't delegate everything to the browser and say that, hey, they now have these tracking prevention mechanisms, that's fine. I can just kind of keep siphoning into my Cayman Island fund and enjoying life. Don't think that browsers have got tracking prevention right. All you need to take a look is that table where every single browser implements the same stuff differently to know that they don't know what's right. They're doing right by them, and they might have their own incentives to do so. And the final thing, which is the biggest do, is there's no excuse to be complacent anymore. All this information is available. The problem with tracking prevention stuff is that it's all over the place, which is one of the reasons cookiestatus.com was created. But here's a good list of Twitter people. Here's a good list of interesting groups on the W3C consortium, or the W3C. So all of these are open. You can join the W3C as a member, and you can join these discussions. There are standards discussions for many of the things mentioned today. You can join those discussions. If you're worried about the death of the third-party cookie, you can vocalize it. You can go there and tell them you're worried about it, and then you'll discuss about your worries. And then here are some websites, some blogs. There's tools like the Panopticlick, which measures your fingerprint. Have I been pawned? A couple of blogs and so on. So huge apologies for going so much over time. I hope this was informative. I'll be here for a couple of hours before I go home. And then we can talk about this all night.